Today, we want to look at functions of two variables. We're going to start upgrading our calculus thinking to deal with functions of two variables. This is where we're just going to start. Start with functions. Functions are nice and restrictive. Good place to start. Here's what we want to think of. We want to imagine that we're just expanding on stuff that we already know. So let's grab what we already know and how it's going to relate to this. When we write an equation like y equals f of x, we have a function of one variable. The graph of this function will be a one-dimensional curve in two-dimensional space. One-dimensional curve in two-dimensional space. For two-dimensional space, we're going to say it's a real space. So I'm going to write a real number, but I want to indicate that it's two-dimensional. So I'm going to call this R2. We're going to write R squared, but we're going to say R2. That's our abbreviation for two-dimensional space. The 2 is a superscript. The R is a double R that we normally use for the real numbers, but we just say R2. Yeah. The two-dimensional space part is because there's two variables, x and y. Everything, we're establishing a relationship between x and y. So the two-dimensional space part is because we're looking at a collection of points x, y. It's a one-dimensional curve because each input has just one output. The output is the height above the x-axis. X comma y. So we're just using y as the height above the x-axis. Since we're only plugging in one thing, we're just getting a one-dimensional curve in R2. Note that not every one-dimensional curve in R2 is going to be a function. For example, if I have a circle of radius 3 centered at the origin, that's not going to be a function. I can't write y as a function of x or x as a function of y. But it's an equation involving two variables, and so it's going to be a curve in R2. But since we're starting our discussion in R3 with functions, let's just start with functions. What we're going to do is we're going to increase everything by one dimension. And so we're going to talk about z is f of x, y. We're going to do this in the same way. Z is going to be the height above the xy plane. Z is the height above the xy plane. So every point on the xy plane, which I'm going to imagine is the floor, we're going to take the x and y, plug it into some function, and it'll give us a height above the xy plane. If I do this for every single point in the xy plane, we're going to produce a surface. So a function of two variables will produce a two-dimensional surface in three-dimensional space. So we'll get a two-dimensional surface in R3. It's going to be three-dimensional space because I've got 3 coordinates to work with. There's an X, there's a Y, there's a Z. We must be in R3. The usual way to picture R3 in rectangular coordinates is to think of the XY plane as the floor and Z as a height above the floor, like I labeled here. So the usual way to draw R3 is to pick an origin, have the Y-axis go a positive Y-axis to the right, the positive X-axis come out the page, so we draw that as at an angle. And have the Z-axis be perpendicular to both the X and Y axis. This is the usual way to draw R3. We had this before. We usually make the positive X-axis go horizontal to the right, and the positive Y-axis go vertical up. But we had to pick a way to flatten out the XY plane so that Z could be the one that goes up. Any questions? Is that okay? Yeah. Yeah. Yep, we're gonna have to figure some stuff out. Right now, we're just naming the parts. So we want to make sure that we notice that each of these axes are all perpendicular. From a literal standpoint, no, they're not, because it's a two-dimensional representation of a three-dimensional coordinate system. But they're all perpendicular. So if we want to label a point, we do the same thing that we normally do. So if X is 3, so I'd count 1, 2, 3 on the X. And if Y is 4, I would count 1, 2, 3, 4 on the Y. And then if Z is 6, I would label this point as 3, 4, 6. What we need to do is learn how to describe stuff and how to think in terms of calculus, think about the calculus things in terms of surfaces in R3, and then move on to, surfaces in R3, and then move on to solids in R4, and so on. So we need to modify our calculus thinking to fit these objects. Right now, we have a lot of calculus thinking that goes along with curves. We need to upgrade our calculus thinking to fit with surfaces. So let's remind ourselves what the calculus thinking was. That's what I said this the last 2 days, and it's going to be the third day that you hear something. But you don't get stuff stuck in your head by hearing it once. The song gets stuck in your head because you heard it a million times. So I try to stay stuff a million times in like 17 weeks. So I feel like, oh, we already talked about this. Well, yes, but it's not stuck in your head yet. When I say, let's talk about the 2 big questions of math, you need to be like, oh, no, I'm never going to get this out. Now, let's talk about the 2 big questions of math. Carry on my wayward son. You can thank me for picking a song that you don't know later. If you do know that song, I'm sorry. All right, sorry. All right, so let's talk about the calculus things and think about modifying them to fit surfaces, not just curves. One of our calculus things was a slope of the line tangent to the curve at a given point. One of the calculus things that we do is think about the slope of the line tangent to a curve at a given point. So we think about a curve, it's like a one-dimensional curve, and we think about a line that just touches it at one point, that glances off of it. We think about a curve. And we think about a line so we've got to think what happens if we replace the curve with a surface. What's our tangent going to look like? Don't answer, just think about it for a minute. Let that sit. Bring to a boil, lower to simmer, wait. So what we want to think about is when we replace this curve with a surface, what do we get for this tangent business? I want you to think about what changes when you trade a curve for a surface. Think about what changes when you trade a curve for a surface. Number 2 question from calculus that we also have to think about. The other question we have to think about what happens when we upgrade our curve to a surface is how are we going to reframe this? We have the area under a curve and above an interval. So we have some curve. And we have an interval. And we calculated an area. And we have to deal with the same question. What happens? What changes when we trade our curve for a surface. Which is curved, we have a tangent line at a point. What happens if our surface is, our curve is actually a surface? What's going to be tangent? What's the point going to be? When we have a curve, we have a curved area under the curve above an interval. What happens if instead of a curve, we have a surface? What's going to be underneath it? What's it going to be above? This is what we want to think about. Now, to make Calculus 3 truly the easiest of all calculus classes, all I have to do is tell you the answers to these two questions right now. But it's only going to work if I tell you right now, so you don't think about stuff in the middle. If I tell you right now, then instantly you'll understand all of Calc 3. I could just hand you the final exam and you would just crush it. But I have to tell you right now, if I wait any amount of time, like any amount of time, then it's just going to be ruined and we have to go through Calc 3 at the normal rate. So I got to tell you right now, the answers to these questions to unlock the secrets of all of Calc 3. But if I wait, like, say, 3 days, then it's just not going to work. It's going to be gone. We have to go through Calc 3 at the normal rate. So are you ready? I'm just going to download all of Calc 3. So the answer to this question for both of these cases is, oh, dang it, look at the time. That's going to do it for today. That's going to do it for this week because Friday is flex day and I'm just going to be online in my office. That's going to do it for this week. I'll see y'all on Monday. Everybody have a good weekend and thanks for playing.